Hi, today's lesson is about satellite motion. It's a really short lesson. There's not too much to it because you already know about gravitational field and gravitational field strength. Now, what's a satellite? A satellite could either be artificial or natural. Satellites are objects that goes around something else. For example, the moon is a satellite of the earth. It's a natural satellite. You could say the earth is a satellite of the sun. The moon orbits the earth. You also have artificial satellites that have been put up in orbit around the earth, and these are used for communication. So these orbit the earth. So the reason why we are looking at satellites is they're all going around in circles around the earth or the sun or any other planet, and what holds them in orbit is the force of gravity. So if we look at satellite motion, the force of gravity, gravitational force between the satellite and the earth is what provides the centripetal force. So if you equate those two, so the centripetal force is given by Fc is equal to mv squared over r, and the force of gravity between the earth and the satellite is given by gmm by r squared. So if you equate the two of them, because they both stand for the same force, the m's cancel out, and so the equation becomes gm over r is equal to v squared, or v, or the speed of the satellite, is square root of gm over r, where m, the capital M, is the mass of the earth, not the mass of the satellite. Okay, and the other thing that I'd like to draw your attention to is this large word, which is called geosynchronous orbit. So if the period of the satellite, that is the time that the satellite takes to go around the earth, is the same as the time the earth takes to spin on its axis, then the satellite would remain, provided it's along the equator, on the same point over the earth all the time. So this is what's largely used in communication. The earth takes 24 hours to go once on its axis to make a whole rotation. 24 hours, when you break it into seconds, is 24 times 60 times 60. So that many seconds. And that's one day. And so if the period of the satellite is the same as that of the earth, then you say it's in geosynchronous orbit. You might also come across another term called geostationary, geo for geography. So geostationary satellites are above the same point on the earth all the time. So geostationary orbits are also geosynchronous, provided it's above the equator. All right, then that's all for today's lesson, and I'll take photos of my notes and post it in Google Classroom. And there are a few questions again from your pink book. Under the questions on gravitational field strength, there are some questions on satellite motion. So if you could do those, then that would be great. And I'll try and post the answers to those questions as well. So bye for now.